thank our sponsor, Trust on Cloud. Trust on Cloud provides the best in-depth threat models available for cloud services. By using a risk-based library of easy-to-understand and contextual controls, our customers have been able to adopt cloud services 70% faster and with greater confidence. Our subscription services help move you from point-in-time risk assessments of your cloud services to a continuous assessment. All right. And announcing the talk, AWS Presigned URLs, the good, bad, and the ugly by Jarom Brown. Here's Jarom.
Awesome. Thanks, Houston. Also, thanks to everybody for coming to the talk. I know the afternoon tracks can be a bit, you're out of steam by then, so I appreciate everybody coming. Today I'm excited to be going over pre-signed URLs and how they can be abused by attackers, and then also spend a little bit of time talking about maybe how we can put some potential preventative controls in place. And yeah, so excited to talk about this with you guys. Cool. So a little bit about me. My name's Jarom Brown. I'm a lead senior security engineer at Capital One. I work on the bug bounty responsible disclosure team. Husband, I'm a father of 4, and then in my free time, I love to hack on different programs, and yeah, could keep me busy forever. So just a little bit over the agenda today. Earlier, just previously, Josh Snyder did a great job introing this topic. So pre-signed URLs, I'm going to spend a little bit of time talking about S3 pre-signed URLs, what they are, how they can be abused, and how we can potentially mitigate or prevent the abuse. And then after that, jumping to the more important part, or more exciting part, hopefully, is pre-signing other AWS services, followed by a demo, some prevention, and wrap up. Cool. So like Josh spoke about, here's a pre-signed URL. So this is an example of a GET object request. You can see that down below it has the whole signing pattern, how that works. Similar to what Josh spoke about. Also, some of the interesting things about pre-signed URLs is they can be done offline. It's a cryptographic function. There we go. And since you don't need to make an API call to sign that, they can all be done offline. No internet access is needed. Let's see. So it feels like every time we do talk about pre-signed URLs, we're talking about S3. This talk, one of the aims is to kind of move away from that and just make it more normal to say or to know that anything can be pre-signed. So pre-signed URLs, they're supported by all the major cloud providers. And this is core to their functionality and how they work. It couldn't be any other way. So also, Josh had a similar slide in here, but maybe a few years ago, pre-signed URLs in the AWS console, you could click a little button and get a pre-signed URL. And now AWS has made it more obvious about what you're doing. So you know that you're getting a pre-signed URL, something that if you were to post it on Twitter or somewhere, everybody else could grab it and they could download that content. All right. So jumping into one of the attack vectors maybe for pre-signed URLs. So let's imagine you're charged at your company with protecting your users. You have a bring your own device policy, tons of users, they're all doing their own thing. You have antivirus running, of course, but it's hard to watch out for everything they're doing. So you have those few troublesome users who always like to install different Chrome extensions. One of them, the Chrome extension, it will go and get a joke of the day and send it to them. But also behind the scenes, it's capturing all of their browser data and sending it to analytics.xyz. So you can kind of see the problem that would come with that. Just because of the inherent nature of pre-signed URLs, those URLs can then be they can be scraped, and the attackers can look through that, download the data, and then they also have your internal sensitive data. So kind of not a big win for the attackers, but not so much for the organization. Also, part of the research that I did build a Chrome extension that did something similar. It's not ready for prime time, but what it does is it's watching all of my browser history, and it's extracting pre-signed URLs, and it's shipping it off to an API that I built. And so it logs the pre-signed URL, the location it was found, and also the account ID. Yeah, and so the way I'm getting the account ID is for every pre-signed URL, you're going to find the access key ID. And so with the access key ID, you can make a call to get access key info, and that will return the account ID. So just a small project, kind of a fun project that I'm going through. Hopefully here, I don't know, in a year, 6 months, whatever, I'll have a nice list of account IDs, and I can use those to do other things that other people have been presenting on today. So hopefully something exciting next year to show. So I'm not sure if Wes is in the audience, but shout out to him for building this awesome tool. For those of you who haven't used Quiet Riot, it's a tool where you can give it an account ID, and it's going to give you back IAM users, IAM roles, services that are in use. I'm also using the account ID on my own to check for public snapshots, RDS, backups, stuff like that. So a lot of fun that you can do once you have an account ID. Let's see, so just a few recommendations for pre-signed URLs, the S3 pre-signed URLs. When you're trying to protect them, try to stay away from resource-based policies because they can be brittle, and scaling those out across hundreds or thousands of buckets can be difficult. SUPs are definitely the way to go. Try to avoid using pre-signed URLs if you value keeping your account ID secret. Also, if you are going to use them, put the SCP in place so that if the URLs are leaked externally, they won't be accessible. And then one last thing is, I see a lot of companies putting, just using an S3 bucket instead of CloudFront. And so with that same there's a technique where you can, or there's a tool called S3 Account Finder where you can give it a bucket and an object name, and as long as that's publicly accessible, you can also get the account ID. So another fun fact, I don't have it linked here, but I think Googling S3 Account Finder will get you that tool. It's also, I think Nick mentions it on his site, which shout out to your site. It's awesome. So, all right, so jumping into the fun stuff here, mentioned any API call in AWS can be pre-signed. So if you think like create user, describe instances, let's see, any of the delete calls, those, as you can imagine, could be scary. Let's see, had some noted here. So if you were to see in your CloudTrail logs at 2 a.m., maybe describe instance, create key pair, create security group, and a run instance, you probably, I don't know, probably wouldn't be the best thing to wake up at 2 in the morning, right? But so you might also be thinking like, as an attacker, so let's assume an attacker is able to get these credentials somehow. They find them on GitHub, someone posts them to Slack, an SSRF, Gray Hat Warfare, any of those places. You come across some credentials as an attacker. You don't use Nick Forget's best practices of staying quiet. You're a noisy attacker, and you just start trying different API calls. Here's 2 of the same API calls using a pre-signed URL. The first one is not source IP restricted, and the second one is. And so as an attacker, if you see that, like either you're gonna be like, oh, too bad, like they've got their stuff under control. I'll try something else, right? So in this scenario, you're most likely safe, right? But what if a determined attacker, someone that really wanted to get in, theoretically, what could they do? Some things that I thought of, maybe they could generate a pre-signed URL, send it to a user. But most likely, everybody has the phishing training going on. They know not to click on these sketchy looking links, right? So that would probably burn the credentials that you had. Someone would figure out what's going on. Sometimes SCPs are maybe too loose and they allow access from any AWS IP. Let's assume the attacker, he tried that and he figured out like, no, these are like very locked down. And maybe the very last one that I came up with, which I built out a small demo, is kind of water hole type attack. And so it assumes a few different things. The stars will have to align, but we all know, like for attackers, the stars sometimes do align. So in this scenario, the attacker gains credentials. They're source IP restricted, but he was able to determine that a user clicking on those or visiting that URL, it would work. So as I was building out this demo, one thing I did, I was like, I need to find the perfect domain. So I bought, what is the name of it? Definitely not safe to click, or definitely safe to click.com, right? So just kind of ease the user into that. Also, I used Dolly, the AI, to generate some images that would keep the user on the page for just long enough for me to execute several of these API calls. So I'm gonna, hopefully this demo here is gonna cooperate, but there we go. So on the left-hand side, correct? Yeah, the left-hand side is the victim, and then the right-hand side is the attacker. So this is him. He's gotten credentials, and now he's figuring out like, hey, these are source IP restricted. So not shown here is him figuring out what IP or what user they're tied to, but let's assume that he was able to do that. And so I built this along with ChatGPT. I built this site here. It helped scaffold out a few of these things. And so what you can see here is as the user visited the link, I created a session for them, log their IP, and I have a few hard-coded actions or commands that can be run. So for those of you in the back, some of those were describe instances, create user, launch instance, create key pair, things like that. So the first command I sent, which this attacker is impatient and noisy, I sent describe instances, and I had the cron looking every 15 seconds from the user perspective. I'll show you the Chrome console here in a second, but what you can see is, so as the user is browsing, I found that I wanted to send him commands, so I'm sending commands directly to this user's browser. And so as he's watching these images in the background, he's receiving commands, and then those are being executed via JavaScript fetch function. And then when the data comes back, I'm able to push that back to the attacker controlled C2, or whatever you want to call it. And so you see the user's already made these calls on my behalf. I have the describe instance response here. I have a create key pair that was done below. And they're just going to keep coming here. So all of this data is coming back to a DynamoDB table, and I'm showing it here. So something kind of thrown together, definitely not production grade, but it got the job done as an attacker. And where are we at here? I think we're almost done. But oh yeah, one other thing too. So it wouldn't really make sense to create a user because he'd probably be source IP restricted. But the thing that is interesting is I was able to create a security group, create a key pair, launch the instance with all of that stuff. And assuming there's not a source IP restriction there, I'd be able to get in. So that determined attacker is maybe one step closer to getting in. And let's see here. So here are all the calls right here. So you can see there's the get command call that it's every 15 seconds, it's checking to see if there's a new command to execute, and if there is, It's being executed via the fetch. Like I mentioned, the response comes back, and the send response sends it back to my server. I think that was pretty much it. So kind of talked through all of this, but just one more time to recap how it worked. The victim visits, he gets a cookie. I'm able to identify him and send him commands. The victim is receiving them and executing them on my behalf. And since he is in one of the calls are being made from an IP address that are allow listed, they're all functioning and working correctly. There we go. So kind of I don't know, I labeled this one boring stuff. I changed the slide last minute, but so how do we prevent this? Easier said than done, right? Don't link credentials. If you are creating or allowing credentials to be created, keep them as short-lived as possible. You can think like, do your users really need the credentials to work for 12 hours, or maybe is 1 hour good enough, right? Just kind of making it a little more difficult for the attackers. Maybe tighten up the data perimeter. If you have your SCP that's allowing access from a large subnet, maybe try scoping that down a bit. Also, I'm not going to go into it now, but Will Bingston, he wrote a great blog post a few years ago called Dynamically Locking Credentials, and that talks about how you can also lock the credentials based on calls and who needs to use them and so forth. And so I was hoping this slide would be somewhere where I could kind of say like, this is how you can detect it in CloudTrail, but the two events, right, they're pretty much the same thing. So one call made from the CLI versus from a pre-signed URL, they're the same minus the user agent, but we all know you can change the user agent from the CLI and so forth. So it would be great if there was a little more data in the CloudTrail events to help with this. I know we have S3 data events, but that doesn't cover all these other ones. So what else? Last slide here. We made it to the end. So just the final recommendations. If you're using pre-signed URLs, consider maybe not using them, putting them behind an API, doing something else. If you have to use them, make sure you're locking them down correctly. And maybe most important is build in your preventions, be vigilant, look for the anomalous calls in your CloudTrail logs and any other data you might have. And if you have the data events for S3, use them, be smart with them, and yeah, and that is it. Thank you.
All right, was there any questions for Jarom? All right. Josh.
I am so not a browser expert, so like I feel like the same origin policy should have protected the user here, but it didn't. And so like, how did that work?
Yeah, so if you were to look at in the browser at the request that came back, the cores came back as wildcard star. So I'm sure it's by design for some reason somewhere, but yeah, that's the reason it worked. And then one other interesting thing that I forgot to mention is it doesn't work with any of the S3 calls, right? So for whatever reason, probably has to do with just the S3 service in general, right? That does fail because of cores, but all of these other things that I tried did work. So for what it's worth, there's another tidbit of information.
Have you seen any gotchas when trying to implement a data perimeter SCP?
Yeah, so luckily I don't have to do that at my job, but I know there are, yeah, definitely lots of experts here, and see the expert. Okay, yeah, but yeah, nothing here.
Any other questions? Looking around.
There's
There's some in the back. All right. Cool.
Hi, I was curious about your thoughts on using like pre-signed URLs for persistence as an attacker.
Yeah, so let me think. So yeah, there's a lot of things you can do. So I guess the pre-signed URLs, you could come at it from like an insider threat perspective, or if you're an outside attacker, right? So the outside attacker using pre-signed URLs, if there was no or like no SCP in place, then you could go and execute whatever you want. But that'd be really similar to the CLI. But yeah, using pre-signed URLs as a thinking through that in my head. Yeah, you could definitely do that just because of the way their pre-signing works. You can specify like how long you want the URL to function for, right? So you could set it as short as a second up to, I'm sure someone knows the answer, hours, maybe days. But so yeah, definitely, that's an awesome thought. Thank you.
I know my employer's probably listening, but I've thought about this, like on exit day, creating a Lambda that generates pre-signed URLs that gives me persistence forever and really makes someone have a bad day. So, good question. Scary question.
Thanks. This was really interesting. So just to this last slide, so if you have an app that serves a lot of files with, like, let's say sensitive data, just to clarify it, what you recommend is that someone writes an API that services that to the user or to the browser instead of directly presenting the pre-signed URL, or because I mean, think what you were saying earlier in the earlier panel was that, or the session was that S3 is very good in just producing a lot of data, but this kind of would imply that there would be a bottleneck.
Yeah, I think it all just depends on your appetite for the risk. If you're just serving like static images, I don't know if it would matter, but maybe if you're generating like customer statements or something crazy like that, maybe it would be an opportunity to rethink that. So I think it all just depends on the situation. Thank you.
I was going to mention Josh's safer pre-signed URL or safer signed URL GitHub project that he mentioned in his talk is a good thing to look at for that.
Awesome.
Any other questions? I think we're good. All right, thank you, Jarom.
Awesome.
Appreciate
Thanks.
it.